Welcome to another presentation on number theory and computation. So I'll be looking at what is called complex numbers. Now what is a complex number? Well, it's a number that has a real part and an imaginary part. So that is, if y is a complex number, then we can express y as a plus ib, where a and b are real numbers, and we can express I as the square root of -1. So I is just the imaginary part, it's called, and of course we know what the root of -1, it is what is called imaginary. It's not real. Now, so A is called the real part of the complex number, y, and B is called the imaginary part of the complex number, y. For example, suppose I have the square root of -4. We can decompose as the square root of 4 multiplied by -1. And using this rule, that the square root of a times b can be expressed as the square root of a times the square root of b. So we can break it up into two different square roots. So similarly, having decomposed the square root of -4 as 4 times -1, we can use this rule and break it up as the square root of 4 times the square root of -1. But we know that from above that the square root of -1 is with the I. So we can now say this is now what? I. This part is I. And then the square root of 4 is 2. So we end up getting 2i. Now, so if you could ask the question then, what is the real part of a complex number? Well, there is no real part. In this case, our A would be now 0. But what is the imaginary part of the complex number? Well, the imaginary part is 2. So there is no real part, but there is an imaginary part which is 2. Okay, so we have talked about real numbers for the last video. So from this we can see that, ladies and gentlemen, that real numbers then are a subset of complex numbers. So real numbers, like that, are a subset. And of course, the symbol of a complex number, which I should have told you, is like a C like that, as complex number, the symbol. So real part is the real numbers are a subset of complex numbers. Okay, let me do an example now for you. Identify which the following numbers are natural numbers whole numbers integers. So we're going to determine which of the following numbers are natural numbers, whole numbers, integers, rational, and irrational. Part I, -4. Well, -4, is it natural numbers? No, because natural numbers start from 1, 2, 3, 4, and so on. Is the whole number? No, whole number is 0, 1, 2, 3, and so on. Is it an integer? Yes. So -4 is an integer. It's also rational. Why? Because every rational number can be expressed as a fraction with a numerator, and the denominator has to be an integer. We can carry a -4 as -4 divided by 1. No, part 2. 1/5. Is 1/5 natural number? No. Whole number? No. Integer? No. Rational? Yes. 1/5 is a rational number. And 1/5 is called one that has a terminating value, because 1/5 is 0.2. It actually finishes, it terminates. It has an exact value. So it's a rational number. Now, part 3 now, 0. Is 0 a natural number? No. Natural number starts from 1. Whole number? Yes. So 0 is a whole number. Is it rational? Yes. Because I can express 0 as 0 over 1. Since I can write 0 as root 16. Now the square root of 16 can be expressed as 4. But I can write 4 as 4 over 1. So what is really 4? Is 4 a natural number? Yes, 4 is natural. Is it a whole number? It's also a whole number. Is it an integer? It's also an integer. Is it a rational? It's also a rational number. So 4 is natural number. Whole number. Integer. And rational. Now the last example now, part 5. Part 5 is the square root of 2. Is it a natural number? No. Whole number? No. Integer? No. Rational? No. It is an irrational number. Why? From the last video, we saw that it has no terminating value. In fact, root 2 is a number that can be expressed in that form where there is no recurrence of any number or is no terminating value, so it is one of those numbers that is irrational, just like pi. So therefore, root 2 is irrational. So thanks for watching this video. So please join us again for the next presentation.